1.6 is on division of polynomials. We have two kinds of division. The first kind is really going to seem very easy, and it is division by a monomial. Division by a monomial. Now, how many terms does a monomial have? One. Okay. So, I'm going to go straight to the MyMathLab. Problem number 1 starts out as, I tell you what, let me just go over here. I have the problem written down. Division by a monomial, one term. Problem number 1, it starts out as 12x to the 8th plus 5x to the 4th over x. Do you agree I am dividing by a monomial?
Yes.
All right, to do these problems, what I'm going to do is separate this into however many fractions I need. I'm going to look at this piece, and then I'm going to look at this piece. Okay, so it looks like 12x to the 8th over x plus 5x to the 4th over x. Each one of these is going to use the quotient rule. So off to the side, I have written quotient rule. What does quotient mean? It means to subtract the exponents if I have like bases, and I do. So I will keep the 12, and then what is x to the 8th over x? X to the 7th. Plus, I have a 5. What is x to the 4th over x? X to the 3rd. And that's all I'm going to do. So division by a monomial really just turns into using the quotient rule. That's all it is.
So I'm confused why we are not putting negative. Why would be that? Okay, I see, because it's a positive.
Yes, it was just an 8 minus a 1 and a 4 minus a 1. Division by a monomial turns into, like I said, just using the quotient rule. So let's look at number 2, and it is 12p to the 6th plus 6p to the 4th all over 2p. And I've only written that again so that you can actually see it here in the classroom. If this denominator is a monomial, one term, and this is, then I can separate it. This is 12p to the 6th over 2p plus 6p to the 4th over 2p. Then I'm going to use the quotient rule. I'm going to divide. What is 12 divided by 2? 6. P to the 5th plus 6 divided by 2 is 3. P to the 4th over P is P to the 3rd. Done. Now I do want to add to that. Yes, sir. Okay, adding them together, yes, I can add them together, but you did put a qualifier on there if they are like terms. Now they are both p's, but this one has a 5 exponent, this one has a 3 exponent, so they are not like terms. Okay? Good point though. All right, I want to do a problem that's like on your test, and it is like question number 21 on your test. So I'm going to make up, I have a problem that's very similar to yours. I'm going to ask you to divide 10x to the 6th plus 12x to the 4th plus 16x squared, and it's divided by 2x to the 4th. Okay, it is division by a monomial, so I can break it. I have 10x to the 6th over 2x to the 4th plus 12x to the fourth over 2x to the fourth plus 16x squared over 2x to the fourth. The first quotient, 10 divided by 2 is 5. X to the 6 minus 4 is 2. First one is just like all the problems that we've done so far. The second one has one little thing that's different. 12 divided by 2 is 6. What do I do with x to the fourth over x to the fourth? They cancel. Now, some people, I hear people say, well, wouldn't it just be x? All right, if it's an x, then what will the power be? What is 4 minus 4? 0. What is the value of x to the 0? 1. And so 6 times 1 is still just 6. Okay? No x. Because if there's an x, what is its power?
1.
1. And it's not 1, it is 0. Okay? That's a very, very common mistake. No x. Write yourself a little note, no x. All right, plus sign. Okay, first I have 16 divided by 2, which is 8. X to the negative 2. Excellent. You did 2 minus 4, which is negative 2. And I'll write that down, 2 minus 4, which is negative 2. Is that okay to leave as a final answer? No, because I will not give you credit for a negative exponent left in your answer. What does this statement right here say? It says, move me, please. Your final answer should be 5x squared plus 6 with no x.
1 over 8.
Well, 8 over x to the positive 2. Why did the 8 not move?
Because it's just to the base.
Yes, only the base that is affected by the exponent moves. So only the x moved. That's why I've gotten in a habit, I keep making this jump around, I've gotten in a habit of circling the base, and it's a visual reminder that that's all that moves. That's a little different than the 2 easy Math Lab questions. It's like your number 21 on your test. Okay? Now, that is division by a monomial. So for number 3 and the rest of the problems, we're going to do division by a binomial. And what this is sometimes called is long division. All right, I'm going to find a little spot. Well, in fact, I'll do it right over here. I'm going to write something that you may have no reason to write down. You may not need this at all. What I want to do is a traditional long division problem with numbers. So you probably don't need to write it down. Let's suppose that I have 3 divided into 1,784. Now I know that you're a big fan of long division. No, nobody likes it. Okay, but we can do it. Now with numbers, you have to worry about place value. With polynomials, what we're about to be working on, you don't have to worry about place value. Polynomials are really going to be easier than numbers. Okay, here we go. You would say 3 doesn't go into 1, so nothing sits above the 1. 3 does go into 17. How many times? 5. So you would put down the 5, and then you would do what? Multiply. You would say 5 times 3 is 15, and then you would subtract. And you would get a 2, and you would bring down the next number. And you would start over and say 3 goes into 28 9 times, and you would multiply. 9 times 3 is 27. You would subtract. You would bring down the last digit, and you would say 3 goes into 14 4 times for 12. And you have a remainder, whoops, I could do creative subtraction. How about a remainder of 2? Now, depending on where you were in your math life, you started out by putting R2 for remainder 2. Then you learned that the remainder could be written as a fraction, and so you put 2/3, and then later you went on and did decimals. We're going to do the remainders as fractions, but they'll be polynomial fractions. That doesn't make them hard. It just means you're going to put this quantity over that quantity. Okay? Now, for this first problem, and this will be in the video, this will be on your notes, I would like you to put your pencils down. Okay? Put your pencils down. And then if you want to, I'll say it all again, but we've got lots of problems that we can do. Okay, so you're just going to watch. My first problem is to divide x plus 4 into x squared plus 9x plus 20. So it's very difficult. Yes.
I'm sorry.
Yes.
Is that 2 or 4? It looks like 2, even on our paper.
This?
Oh, okay. I
Okay.
thought you were talking about the exponent. I'm
No,
sorry.
okay. There's the 2 right there.
Okay.
Okay? All right, so everybody's got their pencils down. They're just watching for a minute, and I don't want you to take your eyes off of this because I'm going to point at things. I want you to see them. All right. I start out, and first of all, I don't have to worry about place value. And I look at just the first term, just the x. And I look at just the first term, the x squared. Now, typically I say, how many times does x go into x squared? Over here I said, how many times does 3 go into 17? That's kind of hard sometimes with polynomials, so I'm going to say it differently. I'm going to say, thinking about this x, what would you have to multiply it by to turn it into x squared? What would you have to multiply x by to turn it into x squared? X? Isn't x times x, x squared? Yes. So, what do you have to multiply x by to turn it into x squared? The answer is x. It doesn't really matter where you write it up there. You can write it here, you can write it here, you can write it here. It just, there's no place value. Some people say, oh, put it over the x. That's no real big deal. All right, so what did you have to multiply times this to get this? The answer was x. So that's where I guessed what I should put up there. But it was a good guess, and I'm about to multiply. X, I'm using the distributive property. X times x is x squared. Oh, I must have been right. X times positive 4 is positive 4x. All right, I'll pause for just a second. Does everybody see that I use the distributive property, whoops, to get that? So now what am I supposed to do next in a division problem? Subtract. Do you remember yesterday when we did subtraction of polynomials, what we did was we changed the sign on the second one? We went through it, I did it in red, and we changed the sign. Well, I'm going to grab my red, and I'm going to draw a little arrow. This is going to be a reminder. This is the second one, and I'm going to change its signs. That positive x squared becomes negative. That positive becomes negative. So when it's time to subtract polynomials, I'm going to change the signs on the second one, and then I'm going to combine like terms. If you've done it correctly, these will always cancel. Now, what is 9x minus 4x? 5x. And what are you supposed to do? Bring that next one down. And now I start the whole process over. I'm looking at just the x and just the 5x. What would you have to multiply times that x to turn it into 5x? 5. So put a plus 5. Not 5x, but just 5. 5 times x is 5x. 5 times positive 4 is positive 20. It's time to subtract, which means I go to my red pen. And what am I going to do? And change those signs.
And they cancel out.
And everything canceled out, which meant my remainder was 0. What's my answer?
X plus 5.
X plus 5. That's division of polynomials. And we're going to do plenty of them. And I'm going to say the same thing. So I'm going to start out with this term and say, what would you have to multiply times this x to turn it into this? And that's the only part of the whole problem that is sort of a guess. It's not really a guess. You really should be able to figure it out exactly. All right, now, those of you who are dedicated note takers, pick up your pens. Okay, so together we're going to work on problem number 4. The divisor is x plus 2, and I'm going to divide into 3x squared plus 7x plus 2. So the problem is written in MATLAB kind of like a fraction, but I'm going to turn it into a problem that looks a little bit more like division. Everybody have it written down? Now, if you wanted to with your fingers, you could point to the x and point to the 3x squared at the same time, or at least get your eyes on those two. I can only point to one thing at a time. All right, what would I have to multiply times x to make it become 3x squared? I'd need a 3. 3 times x would be 3x, but I need it to be 3x squared. So it doesn't need to just be 3, 3x. 3x times x is 3x squared. 3x times positive 2 gives me what? 6x. And because of the way we set up the problems and the way we multiply, like terms have lined up, which is something kind of nice. What's it time to do now?
Subtract.
It's time to subtract, but when I subtract polynomials, I just change the signs on the second one. The 3x squareds cancel. That tells me I must be doing something right. What is 7x minus 6x? 1x plus, bring down a 2. Start the problem over. You're looking at the x. You're looking at this x. What would you have to multiply times this outer x to get x? Now, if I multiplied it by x, x times x would give me x squared.
Just 1.
Just 1. The identity, just 1. 1 times x is x. 1 times 2 is 2. It's time to subtract. I go to red, change signs. Both of those cancel, which means my remainder is 0. You would write down as your answer 3x plus 1. Are we okay? Now I'm going to take just a second. You don't have to do this at all. But you can always check division problems by doing what? Multiplying. You multiply the divisor, which was x plus 2, times the quotient, which is 3x plus 1. And look at those. Those are binomials, which means I'm going to use yesterday's lesson. I'm going to use FOIL. The product of the first, x times 3x,
3x squared.
is 3x squared. The outer product, x times 1, is x. Inner product, 2 times 3x, 6x. And product of the last, 2 times 1 is 2. Just like what happened to us over and over yesterday, the outers and inners turn out to be like terms. I have 3x squared plus 1 and 6 makes 7x plus 2. And does that check? This product is the same as this dividend. So it does check. You can check them if you want to. If you had a remainder, you would then add it on at the end of the problem, because you add the remainder. All right. That was problem number 4. Good, thank you. Glad somebody knows. Let's look at problem 5. In this one, I'm going to divide by x minus 5. I'm going to divide into 4x squared minus 18x plus 1. I start by looking at the first term on the outside and the first term on the inside. Looking at this outer one. What would you have to multiply by x to make it become 4x squared? 4x. See, this gets easier the more you do it. 4x times x is 4x squared. 4x times negative 5 is negative 20x. What do you do now?
Subtract.
And how do I subtract? I change the signs. That becomes negative, that becomes positive. And I always try to do that in a color so that you can notice that it got changed. Those cancel. What is negative 18x plus 20x? It'll be 2x, and it'll be positive because the 20 was positive, plus a 1. Okay? Virtually starting over. Looking at this outer x, looking at this 2x, what would you have to multiply times this x to turn it into 2x? 2. So I'll put plus 2. 2 times x gives me 2x. 2 times negative 5 gives me negative 10. And what do I do? Subtract. So here goes change, change. Those cancel, and I'm left with 11. Okay, I want to make sure that you know how to write your answer. Your answer is 4x plus 2. Now, whatever the sign of the remainder is, that's the sign you put down next. This 11 is positive, so I'll put plus. Put that 11 over, and what's the divisor? X minus 5. And that's what your answer should look like. You'll have to use your fraction tool out of the tool palette. If you checked it, you would use FOIL to multiply x minus 5 times 4x plus 2, and then you would add 11 to it, if you wanted to check it. Let's look at number 6. 6 is more of the same. It's just that it's a little bit longer problem. I'm going to divide x minus 3 into 2x to the third plus 2x squared minus 27x plus 3. All right, starting out. What do you have to multiply times this x to turn it into 2x to the third? I need a 2x to what power? I need squared. Why squared? Because when I multiply 2x to the second times x, I will add the exponents. There's a 1. That's what it needs to get a 3. So 2x squared times x gives me 2x to the third. 2x squared times negative 3 gives me negative 6x squared. Time for the red. Change the sign, change the sign. Those are gone. 2x squared plus 6x squared is 8x squared. And bring down minus 27x. Start over. Question time again. What would you have to multiply times this x to turn it into 8x squared? 8x. Now if you multiply 8x times x is 8x squared. 8x times negative 3 is negative 24x. Red pen time. Change, change. The 8x squareds cancel. I have negative 27x and positive 24x, which is negative 3x, and bring down plus 3. One more time. What would I have to multiply times this outer x to turn it into negative 3x?
Negative 3.
Negative 3. And I don't need the x, so just negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Last time for the red marker. Change, change. So the 3x's cancel, and I end up with negative 6. How would MathLab want this written? Well, I'm going to have 2x squared plus 8x minus 3. Then whatever sign is on the remainder, that's the sign you write down. And then just put 6 over x minus 3. So the sign of the remainder goes out in front of the fraction.
When is this MathLab due again? Tuesday.
I think Tuesday at midnight. But the test is due Tuesday at 10:15. Yes.
So where did that negative 3 come from? Because I fell off like right there.
This negative 3 right here.
Right.
Okay. It came from, this was a negative 3x, and this was an x. And so I said to you, what would you have to multiply x by to turn it into this? Okay? All right, let's go to 7. Now 7, I'm going to rewrite the problem. It says x to the third minus 27 over x minus 3. Now, do you notice something a little funny about that numerator? Does it seem like it's missing a few terms?
Yeah.
Now, notice your powers. I'm going to go back to number 6 for just a minute. Number 6, inside here, it went from an x to the third to an x to the second to an x to the implied first to the constant. Every descending power was there, which was really good because look at the way things lined up so nicely. All right, I'm going to do something on number 7 that's wrong. Don't write it down. Unless you want to write down that it's wrong. I'll write down that it's wrong. If I just jump in here and start dividing, watch what happens. What would you have to multiply x by to get x to the third? X to the second. X to the second times x gives me x to the third. X to the second times negative 3 gives you negative 3x to the second. Do you see an issue? Look right here. Those are not like terms, are they? My x squared term is sitting underneath my constant term, and that's a problem. That's wrong. That will give you a headache. And I want you to feel good. So, here's how you're going to feel good. Start writing, please. This is right. That is, if you are a note taker. I think everybody ought to be a note taker, but they're not. You can always print them out later. That might work better for you. Okay, I'm going to divide by x minus 3. Now, when I divide in, always start with the high power. And the high power is the x to the third, so I'll write it down. Now, I really wish I had an x to the second power, but I don't. You know what? I'm just going to put one there anyway. I can't just add in an x to the second because I want one. Here's what I'd have to do. I'd have to say there are 0 of them. This is called a placeholder. 0 x to the second. All it does is hold a spot for the x squared terms. Plus, I'd really like to have an x, and I don't have one, so I think I'll put one, but what will I have to put as its coefficient? 0. And then I need a constant. Well, I have a constant, minus 27. Every power of x needs to be represented. And if it's not in there, you need to put a 0 placeholder. Okay? This is going to turn out so much better. What do you have to multiply x by to turn it into x to the third? X to the second. Now when I do it, x to the second times x is x to the third. X to the second times negative 3 is negative 3x to the second. In my previous wrong problem, there was an issue. I'm quite pleased with it now. I'm going to change my signs. The x to the thirds cancel, but what is 0x squared plus 3x squared? It's 3x squared. That placeholder kept me from lining up things that weren't alike. And bring down, although it looks weird, a placeholder 0x. And start over. Looking at the x. What do you have to multiply x by to get 3x squared? 3x. So plus 3x. 3x times x is 3x squared. 3x times negative 3 is negative 9x. Change my signs. That gives me the 3x squareds cancel. I have 9x. And what's the last thing I do? Bring down that minus 27. Last one. What do you have to multiply x by to turn it into 9x? 9. So plus 9. 9 times x is 9x. 9 times negative 3 is negative 27. And I'm done. The remainder is 0. Now, I probably should show that at least in my mind I changed those signs. Is that okay?
Why do you always change it?
When you subtract polynomials, if you remember this from yesterday, if I had something like x plus 2 and I subtracted 5x minus 8, when we did that problem in class yesterday,
The last one is positive.
we did change, change, change. And so it is this changing that I'm doing right here. The word subtraction was in my head, and I changed it, and then I changed the signs on the second one. Okay? Last problem. I am not going to do this whole problem. All I want to do is make sure that we can set it up okay. If we set this up, and we have y minus 2, and we're dividing into, this numerator, in case you can't read it okay, looks like this. Is there a missing term?
No, it just
Yeah.
works.
So I need y to the third plus 2y squared. I need a plain old y, so I will have plus 0y plus 9. And then you would go on and do the division. Any missing term needs to go in there as a 0. I'm not going to finish that problem. We're going to call section 5.6, which was division by a monomial. That was the easy part. Long division, much more fun. Yeah, I know. So we're going to call that done.